and nonlinear equations. So right here is a system of linear equations. Let me remind you how I know they're linear. X is to the first. Does everybody see? You look at the power of X. If it's to the first, it's a linear equation. The second one's also linear. So if you think about it, what we're finding is when these two lines intersect, where are they equal? We're not going to solve by graphing. We're going to solve by algebra. So we're going to use method elimination and substitution. It did force us on this one to use substitution. I always pick elimination if possible, but they did say use substitution. So you're going to pick a variable to get by itself that won't create a bunch of fractions. So I'm going to use equation number 1. Stick with me because I'm going to go like mighty fast here. I'm going to add y and I'm going to minus 1. So I have 2x minus 1 equals y. I've just rewritten the first equation as 2x minus 1 equals y. That's not changing it. Changing order doesn't change it. But it's now able to be substituted quite easily. I'm going to take that and substitute it into the other equation wherever there's a y. So it replaces the y. So you have negative 4x. Then you have a plus sign. Then when you do substitution, you have to have parentheses because sometimes parentheses will make or break whether you get it right or wrong. Does everyone see where the substitution was made? From here, you'd say, well, in this particular problem, there's a positive 1 in front of the parentheses, so we don't really need them. Negative 4x plus 2x minus 1 equals negative 5, which is a linear equation. Notice there's all x's, so I know I can solve. So I have negative 2x minus 1 equals negative 5. I'm going to add 1. Negative 2x equals negative 4, so doesn't x equal 2? From there, you'd say, okay, I know that this is an XY intersection point, so 2 comma what? To go figure out the what, you plug it into one of the originals. This is still considered an original because I just reordered it, so I'm going to pick that one. Y equals 2x minus 1. I'm then going to go plug in x is 2. So that'd be 2 times 2 minus 1 is 4 minus 1 is 3. Y equals 3. So the final answer is 2 comma 3. So this is one independent intersection point. That's a vocabulary word they're going to ask. Independent. When you have one solution, it's called an independent solution. That just takes some memorization. So, all right, so look at the 3 things that could happen because this is going to come up. If you have an actual intersection point, it's an independent solution. What if you happen to have 2 lines that are parallel? Well, solutions are where they intersect, so that means there would be no solution. We're not graphing those. So what if you didn't realize they were 2 parallel lines? What's going to happen is algebraically you're going to be solving and all your variables are going to cancel out and you're going to get a contradiction, something inconsistent, like 0 equals 2. If your variables cancel out, you can't solve. So you'd say, what's going on here? Oh, it's a contradiction, so no solution. Anytime you say no solution, the vocabulary word is inconsistent. It's because you have an inconsistent statement. Once again, that would be because you had 2 parallel lines. Now, this is where you need to lock in on. What if you have a line that lands right on top of the line? Well, you have infinite solutions on the line. It's not just infinite solutions. If you say any solution, you mean any point, period. But that's not accurate. Look, any point that lands on the line is a solution. So watch what we do. We would say, okay, yeah, x can be anything. See, I can go anywhere. But then the y can't be anything. Y needs to be the line. Yes, everyone? So it's like, what is the line? Well, right here is the line. So you would say x comma 5/2 x plus 4. See, that's saying any solution on the line. So we have x be the infinite solution, and then this is what's called a dependent solution, because this is the dependent part. It's like, yeah, it's infinite solutions depending on landing on the line. So just so you know, if you get infinite solutions, you would call it a dependent solution. Even for me, that takes some memorization. What if you aren't graphing, which we won't be? What's going to happen algebraically is your variables will cancel out and you'll get a true statement. So 0 equals 0. You'd say, oh, my variables canceled out, I can't solve. It's a true statement, so this will be an infinite solution one. All right, so let's just start practicing. We'll see one of each. So let's solve by elimination. Remember, elimination is when you have variables be exactly opposite so that when you add the equations together, they cancel out. Isn't 3x and minus 3x already opposites? So I'm set up for elimination. I don't need to multiply by anything. Now listen, the one thing you're allowed to do is multiply by a constant. You're not allowed to times by like x or y or whatever. Okay, so we don't need to do that though. Add straight down, the x's eliminate. 4y minus 1y is 3y. When I add up that, I get equals 3, so I'll divide by 3. Y equals 1. So then you would say x, I don't know, but y, oops, what am I doing? X is, I don't know, but my Y value is 1. So now you go plug it into an original. The original I'm picking is 3x plus 4y equals negative 2. I plug in the Y value of 1. 3x plus 4 times 1 equals negative 2. 3x equals, subtract 4, negative 6. Divide by 3. X equals negative 2. I skipped a step because we all know how to solve a linear equation. We all know how to calculate something. So look, everyone, this is what you would say. Okay, we got one independent solution. If they said, what does that look like? You'd say, well, the first one was a line. The second was a line. So it's two lines intersection point. Right, everyone? Yep. Okay, let's do this one. Let's use elimination. So notice the x's and y's aren't opposites, and they also are not, there's not a y value or an x value with a leading coefficient of 1. So let's just focus on x. We need to make these add up to be 0. So let's times this one by negative 3. Why negative? Because one of them has to be positive and one of them has to be negative. So I've got to put a negative somewhere, so I'll just put it there. Then I'll times this by 2. Why? Because I'm timesing by each other's constant, so they're the same thing. So now rewrite the top. Won't it be negative 6x, everyone? Stick with me. Plus 12y equals negative 18. The bottom equation will be 6x minus 12y equals 18.
Oh, so it's infinite.
Good. So when I add straight down, 0 plus 0 equals 0. So 0 equals 0. The variables cancel out with the algebra, and we got a true statement. So we would have to say infinite solutions on the line. So I'm just writing myself a note. If we just say infinite solutions, we miss most of the points because that's really not accurate. It's not infinite solutions. It's infinite solutions on the line. So we'll say x can be anything, but y needs to equal the line. What line? Oh, well, neither of these are in mx plus b form. However, we can get them in mx plus b form. So let's take the top equation, 2x minus 4y equals 6, and get y by itself. So it's y equals. So I'm going to add 4y, if you don't mind, and subtract 6. 2x minus 6 equals 4y. Divide by 4. mx plus b, so that'll be 1/2 x minus 3/2 equals y. We all know how to simplify. That's why I'm going quick. We all know how to simplify fractions, yes?
You can choose either of the equations?
Yeah, because they'll be the same, right? Remember, they're the line on top of the line. So no matter which one you pick, it'll end up with the same exact thing since they're the same line. So that's what we would say. Our final answer is x, comma, the y value is 1/2 x minus 3/2. That's how we would write our infinite solution. And you're right, it's a dependent solution. It's depending on the fact that we have to end up on the line. Okay, good. Okay, let's see one that ends up just algebraically with no solution. So you'd say, okay, you wouldn't know that yet. You'd be like, okay, let's times this by, well, do you want to do y or x? Okay, then you'll times this by negative 2. And this one by 3. You guys said y, so that's where my brain focused. Do you guys see how I'm making them opposites?
Yeah.
One needs to be negative, so I have to make one of them negative. So I get negative 12x minus 6y equals negative 18. The bottom one will be 12x plus 6y equals 36. So notice this time when I add up like terms, I'm getting 0 plus 0 equals 18. 0 equals 18. Our variable canceled out and we got a contradiction, an inconsistent statement, if you will. So this one would be considered no solution. So they said, so what does that mean? You'd say I have two parallel lines. They never intersect. Now, how do I know they're lines? Because it's x to the first on both of them. Okay, so no solution, and then you would say the vocabulary word, once again, this is a hoop jump. The least that I worry about is that you can name it correctly as a inconsistent solution. Okay? So we can all see how that's going to work out. You guys with me? Yeah. Now let's move on to nonlinear. That's too basic for us at our level. Yeah. Like that. Okay. You'll say anything for x, but that's not true for y. Y needs to be the line. So we went and did mx plus b, you know?
Oh, okay.
So that it was like y equals, because we usually write x, y. Do you see what I'm saying? So we wrote what y equals. And it was 1/2 x minus 3/2. Okay, let's move on. Okay, so skip down to here. Okay, I need to be very clear here. So let me say something. I wish they would have done a better example. I wish that this was not x squared. So look at mine. I just scribbled out my x squared for a minute. I need to make a point here. I always recommend elimination, but it's not always possible. So in this case, elimination, look at my problem. I'm not talking about your problem. Remember, I just erased my x squared. In this problem, I could use elimination, but the only one I could eliminate is y. To use elimination, the variables have to be the exact same power. You cannot force something to be the same power. So look, it would not be allowed to say, oh, I'm going to do x and times by negative 4x. Yeah, that would be negative 4x squared, which would cancel out with that, but it's unallowed to times by a variable. Do you guys see what I'm saying? We can only times by a constant, a number. Numbers don't change solutions. Variables do. But we can use elimination in either of these because x is squared and y is squared. Now look, I need to be clear. Let me erase both of these. Elimination would not be possible here. You would have to use substitution. Why? Because neither of those, x is not squared and y is not squared. So you have no choice but to use substitution. You would get x by itself or y by itself and substitute it in. But the good news is we do. So let's times by negative 4. Why? Because I'm choosing to eliminate x squared. So multiply negative 4 into each piece. Stick with me. So that's negative 4x squared minus 4y squared equals negative 16. Now don't get confused here. We're not adding straight down. It might not line up. You're adding up like terms. So what if there's a y and a y squared? Can you add them together? Nope. You'd write y first, then y squared next, or y squared and then y. But this is not what's happening here. 4x squared minus 4x squared is no x squareds. So 9y squared minus 4y squareds is 5y squareds. 36 minus 16 is 20. Now I need to be very clear because it seems like on the test this doesn't happen. Do you guys agree at this point the x's are gone, we only have y's? And it's quadratic. So this should be your thought process. How do I solve a quadratic? Well, quadratics just depend. Now understand, unless, in this case, wouldn't you agree there is no middle term? There's no y value. So we can solve by taking square roots. But what if we would have got this? 5y squared minus 4y equals 20. Can we solve this one by taking square roots? It seems like on the test they have one like this and people freeze.
It's just factor.
You would have to get it set equal to 0 and solve by factoring or quadratic formula. It might even be an ugly one. Do you see? You know what I mean? So they kind of spoil us in these examples. I'm like, what the heck? Because it doesn't seem like on the test they give a ton with perfect, like taking square roots. Because there's no middle term, we'll just divide by 5. Y squared equals 4. We know if we're solving by taking square roots, we need a plus and minus. So we get y is equal to plus and minus 2. I still have people saying the square root of 4 is square root of 2. You guys understand the square root goes away, right? Okay. All right, 2. All right, so now listen, this should be your thought process. I don't know x, I know y is 2. You got to treat them separately. I don't know x, y is negative 2. You then go plug it into one of the originals. Any original works, you're going to pick the one with the least amount of powers. They both were squared on the top and bottom, so I'll just pick x squared plus y squared equals 4. I do bulletin points when I start plugging stuff in. So I have x squared plus 2 squared equals 4. X squared plus 4 equals 4. So won't I minus 4, everyone? It's a, once again though, what if it was a quadratic that that had a x? How would we solve it? Get it set equal to 0, and then we would factor a quadratic formula. This is another one. They're being too easy. They're allowing us to solve by taking square roots. So x is equal to plus and minus 0. Now we know plus 0, negative 0 is the same thing. So we'll just write 0. Let's plug in negative 2. It will not always be the same answer. Sometimes it is and sometimes it isn't. X squared plus y squared equals 4. We're plugging in negative 2. X squared plus negative 2 squared equals 4. X squared plus 4 equals 4. So x squared equals 0. We're getting the same thing.
If it's always going to be a square root, would it always be the same? Is there going to be times where we're not going to plug it into like y squared? It'll be just y.
Yes.
Every time.
Mm-hmm. Yeah. No, that's not a dumb question. Okay. All right. So here we go. Here we go. There's our 2 independent solutions. Questions? They were too easy on us, honestly. They made those whole numbers. I get to the homework and there's like square roots in the answers. And okay, let's do this one. Do you guys want to use elimination or substitution? Then let's times by -4. So we have -4x squared minus 4y squared equals -16. Adding up like terms. Isn't this one minus 13y squared equals 20? Stick with me. Divide. Oh, like I said, I hate that they freaking do this. Every time they're giving us in these examples and then they don't do it on the test, it seems like. This is a quadratic with no y. I just want to say it again. If there was a y, you cannot solve by taking square roots. You'd get it set equal to 0 in either factor or quadratic formula. But we can divide by -13. Y squared equals 20 over -13. We'll square root it. Y is equal to plus and minus the square root of -20/13. Isn't this an imaginary solution?
Yes.
Imaginary solutions are no solutions. Why? Because we're looking at intersections. Imaginary solutions are solutions that don't intersect. We can't see them. So you would say no solution. We're only dealing with real solutions. That means that these never intersect. So if we come across I, you're going to say no solution. Moving on. Okay, listen, we cannot, this is a good one to see. We cannot solve by elimination because the y's and x's don't have both a power of 2. So we have to use substitution. So let's get y by itself by adding 2x. So we rewrote the bottom equation as y equals 2x. You're then going to take that and substitute it into the other equation anywhere there's a y. So there's still this x squared. There's still a plus sign. Instead of a y, there's now a 2x squared equals 5. You got to know your algebra here. Isn't it true that because there's a times sign, I'm allowed to square this and this?
Yeah.
What if it was addition or subtraction? Then you'd have to double distribute. You'd write it out twice. Okay, so we have x squared plus 4x squared, don't we? Equals 5. Then you'd say, what's 1x squared plus 4x squared? 5x squared equals 5. You'd say, oh, I'm dealing with a quadratic. And again, they're being too nice to us. It has no x, so I get to solve by taking square roots. So I first divide by 5, square root. X is equal to plus and minus the square root of 1. I still have some of you on the last test writing root 1. What's the square root of 1? 1. You don't need to write root 1. That's silly. So you would say, okay, these are two separate answers. 1 comma, some y value, -1, some y value. They are not always the same. So you've got to go calculate both. Now listen, you can pick the top or bottom equation. Aren't you going to definitely pick the bottom equation since it has lower powers? Yes. Otherwise, if you pick the top one, if you pick the one with more powers, you could have extraneous solutions that don't actually work. So always plug it into the one with the lowest powers. Okay, so we know that y equals 2x. We're plugging in 1. Y equals 2 times 1 is 2. And then y equals 2 times -1 is -2. There's our two intersection points. Okay, questions. They were non-linear, right? Look, x squared, y squared. I'm just pointing that out. Okay. So, I mean, if you would have to be pretty advanced, and as in, you'd have to remember lots of math here to remember what's happening here. This is a circle. I know that because, obviously, I've done that a lot closer to when you guys have. That's the form of a circle, and then this is a line. So that'd be the two intersection points.
When you do y equals 2x, you plug in 1 and then underneath it. I'm confused about making it -1.
Because I also had to plug in -1. Two separate problems. I should have drawn a new little bulletin point to make sure no one was confused. Glad you asked. Okay, moving on. We're almost finished. Watch this one. This one is nasty. Okay. Okay, when you guys see this one, what would be your natural... last period was this is what I do, but maybe I should be asking, what would you do if it were you?
Probably skip it. Put a question mark.
No, you can't. You can't do that. You can't skip it. Just because something's a little different or weird doesn't mean you can skip it.
Time the X.
Definitely do
Okay,
substitution.
that's where my brain went. Substitution. Is anyone? Okay, I heard two things. There are two options here. So Caleb up here said what I do. I said, I don't want to deal with fractions this whole time. So I went and got a common denominator on the bottom. Because isn't it true when solving, if you get a common denominator, you can then ignore the denominator? That's one way, but last period we did it that way. It worked out fine. It took a while. I honestly don't know if that was the best way to do it. Then I heard Lincoln up here say I'd use substitution. So would you get y by itself here?
Yeah, for sure.
Okay, let's try it. Let's try it. That might be easier than the way we did it. Get y by itself. So won't we add y over?
Negative x squared. Wait.
Let's just add y. X squared plus x equals y. Let's try this way. Let's try it. Here we go. So then what would we do? Take this and put it where?
Y squared.
Anywhere there's a y. Okay, be careful. Just because something feels weird, you'd say, well, that is what we do here. X squared plus x. Why aren't you writing this down? Cutter.
I'm sorry.
Oh, back on the naughty side.
I always been
Okay, so we're looking at this. Now from here, wouldn't you agree that, we might actually want a common denominator after all? Do we really want to deal with a denominator this whole time?
No.
If we get a common denominator when solving, you can then ignore the denominator. So let's write this over 1 and this over 1 and get a common denominator. Isn't this one x and this one x? So they need to be x, right? So I'm going to times the bottom by x, the top by x. The bottom by x, the top by x. Now that we have a common denominator, x, 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 we can literally ignore it for solving. So let's write down what we have. On top, we have x squared plus x squared minus x squared plus x plus, isn't 1 times x, x? Equals, isn't 0 times x 0? Now that's not, it looks kind of nasty, but you'd say, oh, that is what it is. I haven't messed up. Now just don't be this student. It actually works out nicely. Don't be this student. I'm going to square this and square this. That's wrong.
Because it's addition.
You're right. It's addition. That's not doable. We have no choice but to write out x squared plus x times x squared plus x. Let's now distribute. X squared times x squared is x to the 4th. X squared times x is positive x cubed. X times x squared is another x cubed. X times x is x squared. So we have x to the 4th plus 2x cubes plus x squared. You're like, yeah, that's feeling weird, but hey, math is math, so I got to keep going with it. Now won't we distribute our negative through to these pieces? Minus x squared minus x. And then don't we have our plus x equals 0? I distributed my negative, and then I have plus x still, right? Here's my plus x. Are you guys with me? So let's now combine like terms. X to the 4th. There's no other x to the 4th. 2x cubed. There's no other x cubes. X squared minus x squared. Negative x plus x. So this is what we're dealing with. Now that, you should be saying to yourself, oh, that's actually quite simple because I solved by factoring. And isn't there a greatest common factor?
Yeah.
So I'm like, I'm glad I didn't just freeze up, and I'm glad I just went with it. So I pull out x cubed. Left is x plus 2. So now we'll solve. What are we getting for this solution? 0 multiplicity of 3 and x equals negative 2. The multiplicity of 3 only matters if we're graphing, and we know that means it's going to cross through just similar to multiplicity of 1, but we're not graphing, so the multiplicity doesn't matter. So you would say 0 is x, we don't know y. Negative 2 is x, we don't know y. Now you're going to pick one or the other of the very original equations to calculate it. Should we do this one? Because we just have it in that order. So y equals, I'm going to write myself a note, y equals x squared plus x is what we reorder the top as. That's still an original. Reordering it doesn't change it. So now we'll plug in 0. 0 squared plus 0 is 0. Then we'll plug in negative 2. So y equals x squared plus x. We're now plugging in negative 2. Negative 2 squared plus negative 2 is 4 minus 2 is 2. There's my two solutions. However, I'm noticing that one of these is an extraneous solution.
Oh, because you added in
Because look at the originals. You're saying that you can plug these into the originals and everything is peachy keen, which it can be, but also it can be not. Wasn't x equal to 0 in one of these? So if I go calculating this, what's going to happen? I'm going to get a divide by
0.
which is actually an issue, which means it's not that we did it wrong, it's just an extraneous solution. It's a solution we need to throw out because it has an issue. So actually, the only answer was -2, 2. Now, most kids wouldn't have recognized that, but if it does cause an issue in the original, you got to toss it out. Okay. That's the end of the lesson. So you're just going to go work on 6.1. You guys picked up at the door. This is very important. This assigned homework is the rest of the year. So I'm not going to print this again. You're going to keep it the rest of the year. And then you're going to check your answers with mine on Canvas as you go. Ready, set, go.